All right, so this session is about safety. All right, so safety is very, very important with your jobs. Um, I'm not going to say that your job or there is another jobs in the water field that don't require safety, but distribution is definitely probably top among them that have to do with safety issues. Just given the nature of your guys' jobs, dealing with water mains and service lines and so on and so forth. All right. So the introduction to safety, we need to know how to think in terms of safety. Does safety have to be inconvenient? Who should be or why should we be safe and who's responsible for safety? All right. So OSHA, we're going to start talking about excavation and trench safety. So OSHA defines a trench or excavation as any man-made trench that is a cavity or depression within the Earth's surface. So anything that is under 15 foot wide, not length, but 15 foot wide is considered a trench. And then any trenches that are over 5 feet deep or greater, they require protective systems like trench boxes and shoring within the trench itself to prevent cave-ins, right? Trenches 20 feet or deeper require that the structure and restraints of the shoring components be designed by that of an engineer or regulated professional engineer, okay? Meaning requiring a licensed stamp of a PE to sign off on the design of it. So here's some trench things here, and you can see why is trench safety such a big thing. The biggest reason that trench safety is a thing for the fact that you could have a collapse of the outside walls, and the collapse or encavement of the walls could lead to death, injuries, or so on and so forth. I think it was last year in Michigan alone, we had 2 deaths due to trenches collapsing in the state of Michigan last year. I know of one was in the Detroit area, and I think one was just in the rural Detroit area. So the thing about it is with trench safety, there also comes some other things, right? So like trench safety, if any time a trench extends over 4 feet deep, you are to have a ladder within that trench, and that ladder, depending upon the length of trench, you're supposed to have a ladder within 25 feet of all people within the trench at any given point or time. And along that 25 foot, the ladder is to extend 3 feet above the trench edge. All right. So anytime we get over that 5 feet, if we're doing like a water main break or something, a lot of times what you tend to see is trench boxes where municipalities are bringing in pre-constructed boxes and they cut the trench just big enough to sneak in a trench box to shore up the thing. All right. So again, like we were talking about, encavement is a big part of trench safety, but another thing about trench safety that isn't just encavement or engulfment is the fact that hazardous atmospheres. And what we mean by that is if you have a rather deep cut and you have contaminated soils in the area of an underground leaking storage tank or something, it could be that there's heavy industrial solvents or gasolines or anything along those lines that are cause of VOCs. And when you cut into them with a trench, those of you in the trench could be exposed, right? So trenches can be considered confined spaces. And another thing that often happens with trenches is you have vehicles who park too close to the edge of it and their exhaust is blowing down into the trench. And gases like carbon monoxide and that are heavier than air, so they tend to settle on the ground. So if you're down in a trench and there's an exhaust coming out, you could very well be exposed to high levels of carbon monoxide, right? So it's really important too that in some of these trenches to be monitoring the atmosphere, right? Kind of that similar to an enclosed, confined space, because we don't want anyone else to, be harmed due to atmospheric too, other than the sidewalls and stuff falling in. So it's a big thing. And then another thing going on with trenches is the fact that you have moving equipment. Trenches are not just dug for no reason, right? Trenches are dug for installing new water main or repairing new water main, which seems to be the typical, to be honest with you, or even doing service lines. But trenches are typically for, like, at this time of year, especially, is replacing and fixing water main breaks. And there's often going to be a backhoe, and there's going to be a pump flying down on a hose to the guy in the hole to pump out the hole for him, and so on and so forth. Especially if you can only throttle the main and you can't get it fully isolated, for this. So here's some examples of trench boxes. varying in different sizes and depths. A lot of times, like I said, these are kept in the DPW yard and such. And as you can see here in this picture, there was a cave in during the trenching here, but the trench box didn't collapse. These trench boxes are really strong and safe, and they are required in holes that are 5 foot or greater. We typically recommend any hole that's going to have, if you can, it needs to be shored or trench box. There is an exemption to this. Obviously, if in your area that it's all straight cut stone, then the trench is okay without having to be shored up. Up to like, I think the 20-foot thing after that, then it needs to be designed. But in Michigan, we don't run across the stone thing very often. It's not to say that it doesn't occur, but my guess is it's only in parts of the western UP and maybe some in northern lower along the lake shores, like the Petoskey and Sheboygan area where there's lots of limestone. All right. So can be a trench be a confined space? Yes, it can. We talked about this, right? So what are some of the mitigation strategies? It's using a trench box or properly sloping the sidewalls, right? Or shoring the sidewalls properly. You can tier or kind of like cut them at a 45-degree angle for such a distance in order to meet OSHA requirements, all right? The next thing we're going to be talking about is lockout tagout. Lockout tagout is the procedure for isolating something electrical, mechanical, or something electrical or mechanical on and off switches or electrical, mechanical start and stop type things, all right? And the lockout tagout is a tag put in place with initials and certification on who put and placed the lock, all right? Lockout tagout is to be performed on any piece of equipment that has electrical or mechanical capabilities of harming someone, and they are to be placed by the only person who is working on that device or machinery, because it is not to be removed by anyone else either. So if you come up to an electrical panel while someone is servicing a high service pump or something along those lines, you are not to cut off that tag and turn it on, because it will have proper paperwork and indicating who had placed the lock there and so on and so forth. So that the only person who can remove a lock from lockout tagout is the person who placed the lock. It doesn't matter if you're the supervisor. It doesn't matter if you're the utilities director. This law applies to whoever placed it is the only person who can remove it. All right. So what are some of the issues that could happen from electrical, right? It could increase in pressures, and pressures can cause explosions. It can cause machinery to work like hydraulics and so on and so forth. That could then crush or maim someone by breaking arms or legs or something along those lines, or losing fingers. Electricity, especially on high voltage control panels for pumps and transfer stations and stuff along those lines. A lot of times they're 400 and, you talk about 110, 220. Well, a lot of times those things can be 440 or 480. I've worked around those lots of times in my life where things had to be locked out. And, I've had someone cut off one of my locks, and that is a huge no-no. And you can guarantee that I let that person have an earful along with management for that. So another thing is motion, right? Like I said, in machinery, sometimes this stuff needs to be locked out because there could be a start-stop switch that is locked out on these things. And if removed and started, there's mechanical parts that could really harm someone, like on a lathe, or in our thing, it could be pumps, right? It could be pumps that could really interfere us, or something with like on a backhoe or some type of machinery where someone starts a motor or something along those lines. And then vacuum. I know that doesn't seem like a big thing, but what about a vac truck? Absolutely. All right. Some of these things on that stuff create such a vacuum with some of the stuff we work that it could severely break someone's arm or severely damage their arm or something if it got sucked up into one of those things. So here you go. Homer, proving it. Suck your face off with it, right? So with lockout tagout, there should be a policy in place indicating, and your policy should include things like, almost like a chain of custody, but on the tags or the lockout devices that you're using to put the locks on should have some sort of initial on the equipment, so you know who it is, when it was locked out, and stuff like that. You should also communicate, all right? Because if you're going to be doing something that may impact long-term uh, long-term functionality of whatever you're working on, a plan needs to be put in place for stuff like that too, all right? Because you want to minimize the amount of disruption that you're going to be dealing with so that you're not turning off a whole section of a pump that services half the city, right? Or something along those lines. So could you use the physical barriers, right? To stop out with lockout, tag out, like if you know that the stuff, a control panel is in a room and the room has a locking door on it, yeah, absolutely. You could also lock the door as just an added protection, especially if you're in an area or where your locks have been removed actively by people when working on things. So why do we need barriers? We need the barriers. We need the protection because someone could be killed or harmed severely with people ignoring lockout tagouts and turning on equipment or electrical systems that are being worked on by people. It happens every year across the nation. Do I know of any in Michigan that have happened recently? No, but can it? Absolutely. I mean, I was working on a ski lift one time when my lock was cut off and turned on, and I could have had my arm severed by the cable and Bowie wheels because of it. So here's some examples of different lockouts and tagouts, right? And this is a do not open this valve, and you can see that there was 3 locks placed on this. Typically, if you're seeing things with multiple locks, that means they were placed by multiple people. Or it could be just someone is putting on there in hopes that someone doesn't start cutting them off. But I have seen, we used to do this in a facility I worked in where we had multiple locks and we'd have multiple initials on this, so what color lock was by who, so that we knew what was going on. All right. Here's another example of a lockout. This is a quite extravagant one. I think this is on a gate valve is my guess, like on the screw of a gate valve or something like that. Here's one on an electrical panel. As you can see here, again, this one has 4 locks on it. And this is a 100 amp electrical panel. 100 amps is more than enough to kill someone for sure. Here's one on a couple different valves using a wire here so that keeps them from both being turned. And lockout tagouts too, it's real good to have a container and a commonality place where these things can be found, as you can see here. This is a box in a shop containing the tags where you would put initials and do not use. And this is the lockout device itself here that you'd be putting on the things along with the locks with one key. Like I said, these can only be removed by the people who put these things into place. It should not be removed or tampered with by anybody else, the municipality, at any time. All right. I don't care if you're a boss or, like I said, or utilities director. If this was placed by, John Smith is the only one to remove these things. Okay. All right. So confined spaces. Why are confined spaces such a big deal? The thing is a confined space is defined as a large enough for workers to perform certain jobs and has limited or restricted means for entry and exit. So confined spaces are a big issue. First off, in order to enter a confined space, you need to be certified in doing such. All right. And the certification teaches us best practices for people and shows them the laws and regulations that go along with confined space, such as wearing a harness, being connected to a means of evacuating you out if need be. There is certified confined spaces or permit required, which means one or more people have to be up at the top and it has to be in charge by a competent person that signs off on the entry permit for this. And typically the reason why it's permit required is there's something that makes it a potentially hazardous environment to be in, as far as walls falling in, the atmosphere within the area being hazardous potentially. And also it could be wherever you're going could cause serious safety or health hazards. All right. Typically in a permit required one, you're always going to be wearing an atmospheric device to detect anytime the atmospheric levels go beyond what they should be for explosive compounds, for CO2 and oxygen levels typically on these. All right. They're looking for explosive gases that might ignite at any time that could cause harm or injury or death even. They're looking at CO2 and CO levels so that it makes sure that there's enough oxygen for you to breathe, and it has an oxygen percentage too along with that typically. And when you're in these type of places, you're supposed to be wearing a harness. You're supposed to be wearing a retrieval wire so that you can be retrieved if anything were to happen to you without serious injury to another individual who would have to maybe enter the space to evacuate you out. Okay. Remember, these can only be permit required ones are you have one person in charge of these, which is called a competent person. Okay. The confined space examples can be tanks, vessel silos, storage bins, semi-trailers, rail cars, you name it. Trenches can even be considered confined spaces, all right? Tunnels, manholes, pits, vaults, hoppers, and it just goes on and on and on, okay? Anywhere you can think of a confined space, all right? So hazardous atmosphere is a big one, right? This right here is one of the biggest things that I highly recommend that you have a atmospheric detector on this to make sure that levels are fine. Engulfment's another thing, especially in our field, right? We could be down a manhole, it could collapse on us. We're in a sludge tank or a clarifier at a water plant cleaning it out, and maybe the sludge hasn't been removed in who knows how long, and there could be tons of sludge in there that may even be higher than an individual, and absolutely that could collapse on you, right? Electrical shock is another thing that can happen in these, right? A lot of times in the tunnels we're in, if we're in areas and cities that have buried electrical lines, there may even be electricity or possible to exposure to that, all right? So I myself used to wash rail cars out, so I used to do the atmosphere thing quite a bit with checking from that, all right? Another thing is working from heights. OSHA defines anyone who is working at a 6 feet or higher fall capacity is considered working from a height. So pretty much if you're 6 feet off the ground or more, it's considered working from a height, okay? So knowing that with working from heights, if you're using a ladder that according to OSHA rule, you should always have 3 points of contact to the ladder with your given body, be it a harness, be your feet and your arms, counting as 3 or more, okay? So 3 points should always be connected to a ladder when climbing up. Some things, these are some regulations for dealing with people who are working from heights. You have guardrails, which are typically got to be 42 inches or higher and withstand the force of at least 100 pounds. You know, and some of these things you would, 200 pounds, that's not exactly easy finding anyone who's 200 pounds. I mean, there's people who are, but I know I don't fall into that category. I would probably run through a guardrail if something happened. If they're safety nets, right? These should be placed in areas where there's possibly someone could fall, and they got to be able to withstand, 400 pounds of drop weight. They have the personal fall arrest systems, which these, when you're thinking about, this is the most common, to be honest with you. Personal fall arrest systems is kind of just like this picture we back here we see with people being attached to a single point. These single point restraints like this are the fixed, the ones we were just talking about, and they have to be able to withstand 5,000 pounds of pressure on that at any given fixed point of a falling weight, okay? Because some of these, they do have restriction on them where they allow you to go so many feet before it catches you, so to speak. So they usually also involve some sort of climbing harness. As you can see, this is a guy on top of a water tower. And you wouldn't find me on top of a water tower. So, all right, PPE or personal protective equipment. PPE can be a vast number of different things. It can be hats and gloves and safety glasses, special clothing, respirators, self-contained breathing apparatuses is another one. That one's pretty common to have around, especially in water plants, as self-contained breathing apparatuses. But no, sorry about that. But gloves and safety glasses are the most commonly used, along with safety boots, especially in the distribution system. The hard hats too is another thing, because especially if you're in a trench and a hard hat were to, anytime you're on site, OSHA requires along moving equipment that you have a hard hat, because there is moving heavy things moving above your head, and the chance of something falling on your head inside the trench. All right. So level D PPE consists of what you seem to think, like, what if I go out to a main break, this is what I'm going to see, right? Hard hats, safety glasses, steel toe reinforced boots, right? You have to have an ankle at least 6 inches high to help support your ankle and your foot, just in case something were to happen, and high reflective vests or clothing. These are the bright yellow patterned with reflective gear that you typically see, or they can be even neon green, yellow color, or bright orange, typically, or fluorescent orange is where you see these type of things, and they have reflective, right? Hand protection is almost always a must too, because in some cases you're using grinders, sometimes you're using the chain belts, you're using impacts and so on and so forth. And, turning all that stuff can give blisters. It can, gouge your knuckles and so on and so forth when working on different valves in a hole and stuff like that. All right. Hard hats, get clunked in the head if you're down in, if you're up top, get hit in the head by the boom on a excavator, or get, something dropped on your head. All right. I covered most of the stuff. Obviously, we're not going to get to chemicals. It's noon, so let's go ahead and run our last poll question, and we'll go from there.